So in this tutorial, I will solve some examples about the vectors. Okay, for the theory about vectors, you can see the lecture handouts, which is actually quite simple. So, and maybe you also know from some of your earlier physics and other science courses some theory about those vectors. So I will just solve some examples in this tutorial. So example, so suppose, for example, if you have a vector u minus 1, 2, okay, so it is a column vector. Normally we represent vectors in the form of column matrices. If v vector is 3, 0, and w matrix is w column, w vector is 2, 1. So we can compute v plus u plus v as u will be minus 1, 2, v will be 3, 0. So this simple arithmetic says that it will be minus 1 plus 3 and 2 plus 0. So it will be 2 and 2. Okay. If you want to calculate v minus w, so then v, we know that it is 3, 0, minus w, we know that is 2, 1. So it will be 3 minus 2 and 0 minus 1. So it will be 1 minus 1. Okay. If you want to calculate minus 2u, okay, so it will be minus 2 times u is minus 1 and 2. So it will be minus 2 times minus 1 minus 2 times 2. So it will be 2 and minus 4. And then if you want to calculate u plus 2w, so it will be u is minus 1 and 2 plus 2 times w is 2 and 1. So what it will be, minus 1 plus 2 times 2, and then 2 plus 2 times 1. So it will be 4 minus 1 is 3, and then it will be 2 plus 2 is 4. So 3, 4, that will be the answer. Okay, so since these are two component vectors, so maybe we can also represent them on the coordinate systems as well. So normally, for example, what is u? U is minus 1 and 2. So what is the meaning of minus 1 and 2? So if we take the first one is in the horizontal axis, the second one in the vertical axis. So with respect to origin 0, we will take it. So minus 1 will be here, and then 2 will be here. So this will be a vector u, okay, vector u. And then v vector is 3 and 0. So 3 and 0. So in this direction. So if it is x, this is y. So 1, 2, 3. 1, 2, 3. So it will be here. So this will be a v vector. And what will be u plus v vector? U plus v vector is 2 and 2. So it is 2 and 2. So 2 and 2 is 1, 2. 2 is here, and then 2 will be here. So it will be this vector, 2 and 2. Okay. And of course, I mean, from your vector notation, you can also say that if you can translate this vector to its head, and then the final point will be here, and then the resultant of these two vectors, u plus v, will be like that. Similarly, we can represent the v minus w vector. Okay, So v minus w. So what is v? V is 3 and 0, so it's as usual as before. V, and w is 2 and 1, so it is 2 here and then 1 here. So this is the w vector, v and w. And then what was v minus w? It is 1 minus 1, so it is 1 minus 1. So 1 is here and then minus 1 is here, so this will be v minus w vector. Okay, v minus w vector will be here. So in this case, since it is v minus w, so v, and then we have to take minus w. Minus w will be on the opposite side, so if you put the w over here, so then it will be minus w in this direction. So this v minus w will be like this. Similarly, we can represent minus 2u, so 2 minus 2u. So what is u? So u was here before. Okay, this was u, this was v. Okay, so u was here like this. So 2u minus 2u will be 2 minus 4. It should be opposite direction, so it should be 1 2 and then 1 2 3 4, something here. So well, it should be something very much on the opposite end. Okay, so something like this. Okay, this is minus 2u. So if it is 2, if it is u, so minus 2u will be here in this direction. And u minus 2w, so we can represent u was minus 1 and 2, minus 1 and then 1 and then 2. This is u, and then 2w, w is 2 1, so 2 1 2 and then 1. So this is w. So u minus 2w is 3 4. Okay, so this was 2 and then 3 will be here, and then 1 2 3 4. So it is something here. So this will be the u minus 2w. Anyway, you can draw it better on the some graph paper rather than drawing on this sketching on the. But anyway, any these two-dimensional vectors we can represent very easily on this plane of paper. Okay, the next question, example 2 in this case. Example 2 in this case is let's say if we have two vectors u 1 minus 2 and 6, and then v 0 4 minus 1, 0 4 minus 1. Okay, these are the three component vectors. So the question is very straightforward. Find a, or rather state a linear combination, of those two, linear combination of u and v. So by linear combination, what we mean is that, so for example, if we have u, and then for a linear combination, what we can take, we can multiply u by a scalar value. Okay, say maybe a is a scalar, and then we can multiply v by another scalar b by v. So the combination of this will be a that will be a linear combination. So we can take any value of a and b. So for example, we can take a is equal to 1, b is equal to 3. So then 1 times 1 minus 2, 6, plus 3 times 0, 4 minus 1. So that will be the linear combination of u and b. So it will be 1, and then it will be minus 2 plus 12, that will be 12 minus 2, that will be 10, and then it will be minus 3 plus 6. Minus 3 plus 6 will be minus 3 plus 6, that will be 3. Okay, so I don't know, I hope my arithmetic is correct. So this will be the linear combination of u and v. So similarly, by choosing any values of a and b, we can find many linear combinations. Okay, so we have infinite number of linear combinations. Okay, the next example is we can represent a vector equation as a linear system. Okay, so for example, if we have a vector equation in this form, x1 3 minus 4 and plus x2 minus 1 7 is equal to minus 3 0. So we can represent it as a linear system of equations. So in this case, x1 and x2 are the variables, but they are scalars. Okay, they are scalars, so scalars can be multiplied with the vectors. So we can represent this vector equation into the linear system of equations, something like this. So x1 will multiply with 3, so it will be 3x1, and then minus 1 will be multiplied with x2, so it will be minus x2, and that will be equal to minus 3. So this is one set of equation, and this is one equation, and the other equation will be minus 4x1 plus 7x2 is equal to 0. So in this way we can present the vector equation into a system of linear equation. Likewise, we can represent this vector equation 2 0 minus 3 2 0 minus 3 plus x2 6 minus 1 3 6 minus 1 3 and plus x3 1 3 0 1 3 0 equal to 4 4 3 in the form of system of linear equations. So what will be the system in this case? 2x1 plus 6x2 plus x3 will be equal to 4. The second equation will be 0x1, so that will be 0 plus minus x2 plus 3x3 is equal to 4, and the last equation will be minus 3x1 plus 3x2 and 0x3, so there will be no x3 term, so it is equal to 3. Okay, and we can also reverse this process as well. So for example, if we have a system of equations, in this case in another example, we have a system of equations something like this: x1 plus 3x2 is equal to 5 minus 2x1 plus 3x2 is equal to minus 1. So we can represent it into the vector format, something like this. So we can put x1, and then first vector will be 1 minus 2, and then x2, the second vector will be 3 3, and then the vector on the right hand side will be 5 minus 1. Okay, so we can also reverse the operation. Yes, so I will continue a few more examples from this topic in the next video, please.